Hi, ladies and gentlemen. My name is Lim Jiazeng from Faculty of Computing and Informatics, University Malaysia Sabah. Today, I would like to make a presentation, and the title is Eye Tracking Based Emotion Recognition System. Let's start by looking at the introduction. Emotion classification is the task of detecting human emotions, mostly from using facial expressions, verbal expressions, and physiological measurements. Emotion recognition can be done by using different signals, such as non-physiological signals and physiological signals. However, physiological signals are more commonly to be used to classify emotions, since it is more reliable. Many research on emotion recognition have been done by using different physiological signals such as electroencephalograms (EEG) and the galvanic skin response (GSR) signals. However, there is a lack of the usage of eye movement signals solely on the study of emotion detection, but it is in an increasing trend. Moreover, a stimulation tool is required to evoke the user emotions. The most common stimulation tool used is movies and images. However, virtual reality is much less used to present the stimulation. The user will be fully controlled by the VR headset with the presentation of videos, and hence it is fewer distractions in the VR stimuli. The user is immersed in the virtual real-world environment, so it has a better experience as well as more real reactions and response are obtained from the user. For the purpose of the invention is to classify emotions using pupil size from collected eye tracking data with machine learning. Next, let's move on to the background. Emotion is described as a complex set of feelings resulting in physical and psychological changes that affect thinking and behavior. A definition of emotion does not currently have a scientific consensus, since different researchers use different definitions and emotional ontologies. Eye tracking is the approach that measures an individual's eye properties and movements to determine how and where the user's eyes are focusing. Virtual reality is an advanced technology that can create a simulate experience in the virtual environment. Within the VR headset, the user is more concentrated to the stimuli and more accurate response will be obtained. Nowadays, most of the VR is integrated with the eye tracker, hence the eye tracking data can be easily obtained. The next section is the methodology of the investigation. VR is used as the emotional stimuli. The experiments use the HTC One VR headset with the presentation of emotional video clips with arousal valence model to stimulate the emotion of the participants. There was a total of 10 subjects participate in our experiment, while the eye tracking data was recorded using the pupil labs eye tracker. The data and features extracted will be visualized, then it goes to the classification process to classify the emotions. This is the flow of the video presentation. A 5-second preparation will be given before the video started. There was a 10-second rest period before the next emotional quadrants video was started. The video was divided into 4 separate presentation segments according to each of the emotion quadrant classes. The total length of the viewing session was about 80 seconds for each segment of the emotional quadrants stimuli presentation. The eye tracking data were recorded using the Pupil Labs application that is included with the eye tracker. Pupil capture was used to record the pupil data, while the pupil player was used to export the recorded pupil data. Support vector machine with radial basis function kernel was chosen as the machine learning classifier to classify the emotions into 4 distinct classes, representing each of the quadrants. So this is the interface of pupil capture, the application of the Pupil Labs eye tracker, which is used to record the eye tracking data. So this is the original source code and backend script when running the classification task in Python programming language. Now, let's move on to the result. There are 3 experiments have been conducted with SVM by parameter tuning to obtain the best accuracy. The 3 experiments have been conducted in this investigation with SVM by parameter tuning to obtain the best accuracy. From the result, the highest accuracy obtained from experiment 2 was 57.05%, while the highest accuracy in experiment 3 was 56.98%. However, experiment 1 shows the best performance compared to the other two experiments. The highest accuracy achieved was 57.65%. For the usefulness of this invention, eye movement signals provide an individual's vision localization and allow for direct observation and precise pinpointing of what attracts their attention. Eye tracking data can be collected by an eye tracker or a camera. The eye data collected with the trained model can be used to recognize emotion. In VR, it is allowed to observe the behavior of the user. Eye tracking can be applied to virtual reality to improve gaming experience through the emotions of a player. In terms of a medical perspective, a psychologist will be able to assist in identifying the psychological condition of the patient. For the commercial potential, it only needs a simple camera to obtain the eye tracking data. It also requires significantly fewer sensors to implement in the recording devices. Hence, eye tracking technology can be widely deployed in the future. The eye tracking technology can be applied to the mobile phone and display the emotions on the screen. There are several types of eye tracker are available in the market. In intellectual property right, for the copyright, the video is presented using the original recording script in C# programming language and the training model with the original coding in Python programming language. For the funding, this work was supported by the Ministry of Science, Technology and Innovation. As a conclusion, emotion recognition using eye tracking technology is promising in the future since it only requires a simple setup and installation. Eye movement signals allow us to identify what attracts user attention and observe their behaviors. They can be important indicators for context-aware environments that contain complementary emotion recognition information. Virtual reality creates any kind of immersive world for the users, while eye tracking offers insight into where the visual focus of an individual is at any movement of experience. Furthermore, eye movement signals can be utilized for monitoring the behaviors of VR users. That's all for my presentation. Thank you.